Hello, lovely people. I hope you are doing well. Here we have a 5 a day on the GCSE Further Maths. So let's get right into it. So we've got a cuboid and they're asking us to calculate angle CEG. So first things first, let's actually identify what that even is. So CEG. So I'm going to draw a line from C to E. That'd probably be good. So C to E, wow, that's a terrible line. Oh my gosh, that's really bad. Let's try this again. C to E, I think that's okay. C to E, wow, why is it doing that? One more time, first time lucky. Yes, C to E to G. Okay. Okay, that's okay. That is all right. So that is the triangle that we're looking for. So notice how we've got one side length that we know, but there's a side length that we need to work out using Pythagoras. Okay, so E to G, we can work out because we've got this other triangle here. So I'm going to draw it out over here. Oh, there. So this is 7, this is 3. So this is, by Pythagoras' theorem, 7 squared plus 3 squared square rooted. So the square root of 7 squared plus 3 squared, which is equal to the square root of 58. Okay, and then I've got this triangle CEG, which I'm going to put here, just roughly. So that's E, that's C, that's G, that's the square root of 58, 4. Okay, and then they're asking us to work out CEG, which is this angle here. So using trigonometry, if this is opposite and this is adjacent, we are using tan. So tan theta, opposite and adjacent. In particular, we can see that tan theta, opposite is 4, adjacent is square root 58. Drawing our little triangle out. So we can see that tan theta equals 4 over the square root of 58. So theta equals inverse tan of 4 over the square root of 58. Now, do I even have the calculator to be able to do this? Let's see. So I think we can do this. So let's go. We've got inverse tan or arctan of 4 divided by, where's my square root button? Square root of 58. And that's about 27.7 degrees. So 1 decimal place. Okay, lovely. Next question. Let's change color as well for the next question. So we want to rearrange this to make W the subject. So first things first, I want to multiply both sides by 4W so that I don't have a fraction, which is, nice. So if I multiply both sides by W, I get 4WY, which is equal to 2A times by Y plus W. And then I expand, I get 4WY equals 2AY plus 2AW. Now what I'm going to do is get everything with W on one side of the equation and everything without W on the other side of the equal sign, should I say, of the equal sign. So if I take away 2AW, I get 4WY minus 2AW. That is equal to 2AY. Then the whole point of this is that I can now factorize the W. So I get W, open bracket, 4y minus 2a. And that is equal to 2ay. Now, w is then equal to 2ay all divided by 4y minus 2a. And there we go. That's the value of w. W rearranged. Next, we've got an identity, and it says to work out a and b. So first thing we need to do is expand and simplify, or collect the like terms, as it were. So I'm going to change colors again. I'm like a chameleon. If I multiply things out, I get 4a times 2x, which is 8ax. 4a times 5 is 20a. 3 times ax is plus 3ax. 3 times 1 is plus 3. And that is identical to b minus 33x. Okay, if I were to collect the like terms, the things that don't have x's, that is 20a plus 3. So that's one thing there. I'm going to put that in brackets. And the thing with x's, that's going to be 8ax and 3ax. So that's plus 11ax in total. And that is equivalent to b minus 33x. Now, what we can do here is we do something called comparing coefficients. If you look at the bits that have x's, that's going to be 11ax. That's going to have to be equal to minus 33x, because if they're identical to each other, then the x's must be the same. Cancelling the x's gives us 11a is equal to minus 33. Then dividing both sides by 11, I get a is equal to minus 3. Now I can do the same thing with the bits that don't have x's, again, comparing coefficients. So we have 20a plus 3 is equal to b. And remember, we've worked out that a was equal to minus 3, so that's 20 times minus 3 plus 3 is equal to b. 20 times minus 3 is minus 60, plus 3 equals b. So that's minus 57 is equal to b. That's our answer. Okay, let's keep going. The point A lies on the curve y equals x squared minus 2x plus 4. The x-coordinate of A is minus 1. The normal at A also intersects the curve at B. Work out the coordinates of point B. So we're seeing this word normal, which implies we need to differentiate. We need to differentiate, so work out dy dx. Then we need to find out the gradient of that normal, and then we use y equals mx plus c. Let's go through the steps. So firstly, we have dy dx. That's going to be, well, x squared differentiates to 2x, bring the power down in front, take away 1 from the power. And minus 2x just differentiates to minus 2. So that is going to be 2x minus 2. Then, because we're working out the normal at A, we need to know what dy dx is at A. So at A, i.e. x equals minus 1, dy dx equals 2 times minus 1 minus 2, which is equal to minus 2 minus 2, which is minus 4. So therefore, the gradient of the normal means at right angles. So the tangent would have a gradient of minus 4. So if I do a rough curve, the tangent would have a gradient of minus 4. Therefore, the normal would have a gradient of a quarter, the negative reciprocal. So the gradient of normal equals a quarter. Okay, and now we can use y equals mx plus c. So y equals mx plus c. Before we can do that, well, and we also know that because m equals the gradient, that is a quarter, we've got y equals a quarter x plus c. What we need to do first, though, is work out what the y-coordinate is. So the y-coordinate is minus 1 squared minus 2 lots of minus 1 plus 4, which equals 1 plus 2 plus 4, which is equal to 7. So we've got the coordinate essentially minus 1, 7. Now we can work out the value of c by substituting sub x equals minus 1, y equals 7. So we end up with 7 equals a quarter times minus 1 plus c. 7 equals minus a quarter plus c. So c is 7 and a quarter, or we can say it's equal to 29 over 4. So therefore our equation, the equation of our straight line, is equal to y equals a quarter x plus 29 over 4. Y equals a quarter x plus 29 over 4. Okay, and then it says that the normal at A also intersects the curve at B. So we've worked out the equation of the normal. Now we need to work out where it intersects the curve again. Okay, so if it's meeting the curve again, just to give a visual, we're basically solving simultaneous equations at this stage. So let's change to blue, I think that is. It looks like it's a slight blue. So when this intersects this curve here, y equals x squared minus 2x plus 4. Conveniently, y is equal to a quarter x plus 29 over 4, but y is also equal to something else. So we can put the two things equal to each other. So we have x squared minus 2x plus 4 is equal to a quarter x plus 29 over 4. Now, I don't know about you, but I'm not liking these fractions. So I'm going to multiply everything by 4. So I get 4x squared minus 8x plus 16 equals x, because a quarter times 4 is just 1, so it's 1x, plus 29. Taking everything to one side, I get 4x squared minus 8x minus x is minus 9x. 16 minus 29 is going to be minus 13. And that's going to equal 0. Now I need to actually solve this quadratic equation. Are there any nice things that I can do? Can this factorize? 4 times minus 13 is minus 52, but that's what, 13 times 4? Oh yeah, that works. Okay. So 4 times minus 13 is minus 52. Two numbers that multiply to give minus 52 but add to give minus 9 are minus 13 and plus 4. I'm going to use my factorization hack. So 4x squared minus, no, not even 4x squared. Not even 4x squared. It's going to be 4x minus 13 and 4x plus 4, all divided by 4. This is using my ultimate factorization hack. Do check that video out. And I can see here that this second bracket divides by 4, so I get 4x minus 13 bracket x plus 1 as the factorization. So one of the solutions is x is equal to minus 1. So let's just write this clearly. So 4x minus 13 equals 0, or x plus 1 equals 0, which means that x is equal to 13 over 4, or x equals minus 1. Now, it makes sense that one of our solutions is x equals minus 1 because it already touched the normal at one point and it told us that it was when x is equal to minus 1. So this is almost like a assurance that we've got this correct. Now, other solution is x equals 13 over 4. Now, to work out what the y-coordinate is, I'm just going to substitute this into one of our equations. I'm going to substitute it into the normal because it seems like it might be easier. So at x equals 13 over 4, y equals a quarter times 13 over 4 plus 29 over 4. And that is going to be equal to what? 13 over 16 plus 29 over 4. But 29 over 4 is the same thing as 116 over 4. So 116 plus 13 is 129. So y equals 129 over 16. So our coordinates finally are 13 over 4, comma, 129 over 16. That was quite a long one, to be fair. But once you know the steps of working out equations of normals, equations of tangents, and things of that nature, it's the same steps, just a bit long. That's it for now, guys. Take care.